Again, let us continue with the colligative properties. A little review. When you say colligative properties class, these are properties of the solution, okay, that is dependent in the amount of solute being dissolved in our solvent. So either you add more solute or you decrease the amount of the solute, there will be an effect in the colligative properties. So we only have 4 colligative properties. We have the vapor pressure lowering, boiling point elevation, freezing point depression, and there is an increase in the osmotic pressure. So yesterday, we started our discussion about vapor pressure lowering. So when you say vapor pressure, it's the pressure of the gas. The pressure resulting from the conversion of the liquid into gas. So if you're going to add more solute, especially if the solute is non-volatile, it will result to the lowering of the vapor pressure, okay? And that will also consequently result to the decrease in the rate of evaporation of our solution. So just like when you add water to alcohol, the tendency of the alcohol to evaporate easily will actually decrease. So if we are going to compute for the vapor pressure, we will really observe there that there is a really lowering of the vapor pressure. So we have here the Raoult's law that governs the vapor pressure lowering of our solution using this formula. Vp, or the vapor pressure of the solution, is equal to X, X being the mole fraction, and i-multiply siya with the vapor pressure of the solvent. So we are done with both problems here for the vapor pressure lowering. Do you have questions before we'll proceed with the boiling point elevation? Wala? Sige. So we also started our discussion about boiling point elevation. When you say boiling point elevation or boiling point itself, this is the temperature wherein the atmospheric pressure or the environmental pressure, it's outside the system, will be equal to the vapor pressure of the solution. So pag mag-equal na yan, again, there will be boiling point. And if we are going to add more solute in the solution, that will result to the increase in the boiling point also. Okay, so again, colligative property ito ha, dependent on the amount of solute. Again, if you are going to add more solute to the solution, then there will be an elevation, there will be an increase from the original boiling point of the solvent. And we are going to use these formulas. Marami tayong formula for this one. Our main formula for the computation of the change in the boiling point temperature is this one. So change in the boiling point temperature is equal to kBm. So kb is constant. We have a table for this. I told you yesterday that I am not requiring you to memorize the kb of all our solvents. You can just make an index card and write the table there to aid you during the quizzes and the exam. And then the small letter m here is the molality of the solute. Okay, molality. So we are done with this in your Chem 101. When you are asked to compute for the molality, our formula is molality is equal to moles of solute over kilograms of solvent. So do not forget to convert the amount of solvent into kilograms. If it is pure water, do not forget also that 1 gram is equivalent to 1 ml. That is for pure water only, that is not applicable to other solvents. Okay? Sige. So this is the table. This is the boiling point here. These are the boiling point of our available solvents in the laboratory. And adjacent to that is the Kb in Celsius per molal. Okay, no need to memorize that one. No need to memorize also the boiling point, but I believe that you are very familiar with the boiling point of water. That's 100 degrees Celsius. And then later, as we discuss, as we are going to discuss the freezing point depression, we will also use this table for the computation of the freezing point of the solution when we are going to add solute. Okay? Actually, almost the same yung way of computing the boiling point and the freezing point. So yesterday, we also computed problem number 1. So I think let's start with problem number 2. So we have here, find the boiling point of a solution of 92.1 grams of iodine in 800 grams of chloroform. So chloroform is CH3Cl. Assuming that the iodine is non-volatile and that the solution is ideal. Okay? So our solvent here is chloroform and iodine is being added. So we are asked to compute for the boiling point of the solution if this is the case. So remember our formula. Wait lang, ba tayo niyan? Shimuagi. What was our formula again? We have change in the boiling point temperature is equal to kBm. Okay? So kB is found in the table. Again, our solvent is chloroform. So let's go back to the table. Let's look for chloroform. Chloroform's boiling point is 61.26 and the Kb is 3.63. Okay, so this is 3.63 here. Remember the unit, degrees Celsius per molal. Now, looking at the problem, molality is not given. So before we can proceed with the computation, we have to compute first for the molality. So what was our formula again sa molality? Wait lang. I need more space. Okay. So molality is equal to moles of solute divided by kilograms of solvent. Now, we have here 92.1 grams for our iodine, which is our solute. And then we have 800 grams of chloroform, which is our solvent. Now we need moles for the solute. Therefore, this 92.1 grams of iodine should be converted to moles first. So we have here our formula. Moles is equal to the weight of the substance divided by its molar mass. The weight is 92.1 grams divided by the molar mass. Kindly check for iodine. This is I2 ha. So dalawang atoms yan ng iodine. Kindly check the atomic weight of iodine. I don't have periodic table here.
127 po, ma'am.
Okay, 127. So 127 times 2 is 254 grams per mole. So this is 254 grams per mole. So let's divide. Again, let's be patient with a lot of numbers here. We'll round off sa final answer na. So this is 0.3625 984 252 moles. So yan yung gagamitin natin. 0.3625 984 252 moles. And then divide it with the kilograms of the solvent. Again, our solvent is chloroform and 800.0 grams yung given. We need to convert first sa isang kilogram. We have 1,000 grams. So 800 divided by 1,000 is 0.8 kilograms. Okay, so let's divide so that we can get the molality. Wala na kayo space. So 0.3625984 divided by 0.8. The answer is 0.4532480,315 moles per kilogram, or we can simply write small letter M. So we have now the molality class. We can proceed with the computation of the change in the boiling point temperature. We will multiply this one. 0.45324. This is 4,324,80315 molal. So if we are going to multiply, cancel the small letter M. Answer na sila. Okay. Sige, let's see if that is correct. So, i-multiply natin times 3.63. This is, the change in boiling point temperature is 1.645290354 degrees Celsius. But we are not yet done, since the problem is not asking for just the change in the boiling point temperature, but the boiling point mismo of the solution. So I've given you our formula for this, our final boiling point. Final boiling point of the solution is equal to the original boiling point or the initial boiling point. That is the original boiling point of the solvent, yung wala pang naka-add na solute, plus the change in the boiling point temperature. So, again, I forgot tuloy the boiling point of our chloroform. Let's go back to the table. It's 61.26. 61.26 degrees Celsius. Again, this is 61.26 degrees Celsius plus the change in the temperature is 1.645290354 degrees Celsius. So the boiling point of our solution now is, wait lang, 1.645290354, 62.91. Let's just round it off to 2 decimal places. 62.91 degrees Celsius. So this is now the new boiling point. Okay, tama. 60.953. Okay, that's correct. So again, if it is just pure chloroform, it will boil at 61.26 degrees Celsius. But if we're going to add 92.1 grams of iodine in 800 grams of the chloroform, the resulting solution will boil at 62.91 degrees Celsius. So as you can see, there is elevation of the boiling point temperature as we add the solute. So this one is an example of colligative properties. There is really an increase or a difference in the boiling point if there is an addition of the solute. So it is dependent in the amount of the solute. Questions or clarifications? Meron bang gustong clarify? Wala. Okay. So let me clear the writings on the screen and let us discuss freezing point depression. So the third one for our colligative properties is the freezing point depression. So it's actually the opposite of the boiling point. If the boiling point will increase if you add solvent, it's the other way around for the freezing point. It will be lowered if there is a presence of salt or solute. Okay, so when the freezing point is depressed, this means that the temperature must be lowered before a given substance freezes. That's what you mean by freezing point depression. Okay, again, if the freezing point is depressed, you need a lowered temperature also for the solution to really freeze. Okay, so the presence of the salt or the solute will cause that lowering. Okay, pag mag-add tayo ng solute, bababa ang freezing point ng ating substance. So when you say freezing, I believe you are familiar with that. We have the phase change of a liquid into solid. So in the computation of the freezing point depression, we are going to use this formula. So the change in the freezing point temperature or freezing temperature is equal to Kfm. So this is what I mean when I said a while ago that the computation or the manner of computing the freezing point is almost similar to that of the boiling point. It's just that we are going to use Kf instead of Kb. Kasi Kb is specific for the boiling point. This time, Kf is still a constant, but this one is specific for the molar freezing point depression. And this is also unique for each substance. You don't need to memorize this. We have a lot of chemical substances in the laboratory. Now, multiply that to small letter m. So small letter m is still the molality of the solute or the solution. That is the concentration. We are going to use molality as the expression for the concentration of our solution. So if we are going to let us go back to the table and let's see there. Okay, on the right side of the table, you will see the freezing point also of our solvents in the laboratory, and just beside the freezing points, we have the Kf. So this same unit with that of the Kb, it's degrees Celsius per molal. Okay? But a different na values, do not be confused. Use Kb if you are computing for the boiling point and use Kf for the freezing point. So we have here freezing point of water, that's 0 degrees Celsius, and Kf will be 1.86. We will use this table for the computation of the new freezing point. And for the molality, that will be the same formula, moles of solute divided by kilograms of our solvent. Okay, so let's have an example. What is the freezing point of the 0.33 molar solution of non-volatile, non-electrolyte solute in benzene? Okay, again, what is the freezing point of the 0.33 molar solution of non-volatile, non-electrolyte solute in benzene? Okay, listen. So the same manner of the computation. This is the change in the freezing point temperature is equal to Kfm. KFM. So, what is our solvent here? It's the benzene. So we are going to use the KF of benzene class. Let's just go back to the table and look for benzene. Benzene freezes at 5.5 degrees Celsius and the KF is 5.12. Okay? 5.12. So this is 5.12 here. And then the unit is degrees Celsius per molal. And then looking at the problem, we don't need to compute for the molality anymore because it's already given. So we have 0.33 molal. Cancel the molal. So this is 5.12. 5.12 times 0.33. And this is 1.6896 degrees Celsius. But this is just the change in the freezing point. What we are looking here is the freezing point mismo. So freezing point temperature. So in computing, for the final freezing point, our formula will be, drawing ng change. Wait lang. Let me erase that. So we have here the final freezing point, or the new freezing point for our solution is equal to the initial freezing point, yung original freezing point of our solvent, minus, take note, the difference sa boiling point and the freezing point is, sa boiling point, we're going to add the change in the boiling point temperature, but this time, for the freezing point, we will subtract. So minus the change in the freezing point temperature. So in this case, the initial for the benzene, tinignan natin yan kanina sa table, ng freezing point ni benzene is 5.5 degrees Celsius. If you have access of the table there, you can verify it's 5.5 minus the change in the freezing point is 1.6896 degrees Celsius. Therefore, our freezing point here, 5.5 minus 1.6896, it's 3.8, isulat ko na lang siya lahat. 3.8104 degrees Celsius. Okay? So that is now the new freezing point of the solution. If it is pure benzene at 5.5 degrees Celsius, the benzene will already freeze. But if we are going to add solute and then the concentration of the solution is 0.33 molal, as you can see, there will be lowering of the freezing point. That is 3.8104 degrees Celsius. So it will take a lower temperature before the solution freezes. Okay, questions about this one? I hope everyone can still follow our computation. If you have questions, you may always raise your questions. You can unmute your microphone or you can send your questions in the chat box. Sige. So let us proceed. So I want you, this is a different problem. But I want you to try solving this problem. Kindly read the problem, understand it, and just try to solve the problem. The one who gets the correct answer will be exempted sa next quiz. Pag-quiz mantahan eh. So, if exempted, ang ibig sabihin ko niyan is perfect ka na diretso sa next quiz natin. Sige, I'll give you time to answer. Sige. A solution, anong time na? Let's, hanggang kay, okay, 8:7. Slow ba? Ayan, a solution of 4.00 grams of a non-electrolyte dissolved in 55.0 grams of benzene is found to freeze at 2.32 degrees Celsius. So what is the molar mass of this compound? Baliktad ha, baliktad yung problem. We are going to look for the molar mass of the compound and take note that the freezing point is already given in the problem. The freezing point is already given in the problem. So baliktad yung ating pag-compute nito. But we are going to use still the same formula. Change in the freezing point temperature is equal to Kfm. Ayan pa rin yan siya. Kaya lang, baliktad. Una, ang i-compute muna natin is the change in the freezing point temperature gamit yung last na formula natin kanina. Yung freezing point final equals freezing point initial minus the change in the freezing point temperature. Kasi yung freezing point na final, given siya sa problem, that's 2.32 degrees Celsius. Tapos yung initial naman, you can always look at that in the table. Our substance is benzene. And again, benzene freezes at 5.5 degrees Celsius. Asan na yun? Okay, wait. This is 5.5 degrees Celsius here minus the change in the freezing point. So since this is subtraction, we will do transposition. So itatranspose natin itong 5.5 sa kabila. This becomes negative 5.5 degrees Celsius plus 2.32 degrees Celsius. Ang maiiwan dito, negative change in the freezing point. So, negative 5.5 plus 2.32 is negative 3.18 equals negative change in the freezing point. So this is negative. Both of the sides are negative. So let's multiply both sides with negative 1. Therefore, our change in the freezing point is 3.18 degrees Celsius. So yan yung gagamitin natin here, class. This is 3.18 degrees Celsius. And what was the Kf? So daw, ma'am, this is the Kf. Wait lang. For benzene, again, the Kf is 5.12. Medyo mahirap kasi ito na problem. Kasi baliktad siya. So this is 5.12 degrees Celsius per molar here. Meaning ang hinahanap natin, class, is actually the molality before we can really compute for the molar mass. So divide both sides with the 5.12 degrees Celsius per molar. 5.12 degrees Celsius per molar. Cancel this. Cancel the degrees Celsius. So the molality of the solution, 3.18 divided by 5.12 is 0.6210935. Molar yan siya, molar. Okay? So we have now the molality And then, medyo mahaba ito. Be patient. Molality is equal to moles of the substance divided by the kilogram of the solvent. Now, the molality has been solved already. This is 0.62109375. Let's just use moles per kilogram so we can cancel the unit easily. And then for the moles, we are going to look for the moles actually. And then the kilograms of the solvent, this is 55 grams. So we need to convert that first. 55 grams times sa isang kilogram, we have 1,000 grams. So cancel the grams. 55 divided by 1,000 is 0.055 kilograms. Okay, so yan yung ilalagay natin dito. Ay, hindi mo siya mo agi. 0.055 kilograms. Okay? Cross multiply, you will have the moles here. Multiply natin sila ha, and then makakancel si kilograms. So 0.055 times 0.62109,375. Medyo mahaba ito. 0.03416015625 moles. Pero, moles pa lang yan. Ang hinahanap sa problem is the molar mass. So, we need to use our formula for moles. Let's put a division here. Moles is equal to weight of the substance divided by its molar mass. Ito yung hinahanap natin, class. Molar mass. Ang moles na compute na natin 0.03416015625 moles. And then the weight is given in the problem. It's 4.0 grams. And then we are looking for the molar mass. Cross multiply, you will have 0.03416015625 moles times the molar mass equals, ang naiwan sa kabila is the 4.0 grams. Divide both sides with this number. Cancel. Medyo mahaba, 0.0314. Hindi ko na siya isulat. Kasi wala na akong space. But ito yun. Ito yung lahat na numbers. So molar mass is equal to 4 divided by 0.3416015625. A round off to 2 decimal places. The correct answer is 117.10. Take note of the unit, grams per mole. Grams per mole. So who got the correct answer? 117.10 grams per mole. Ito mga nakakuha ng tamang sagot, kindly send me your solution. I want to see your solutions, class. Ito mga nakakuha lang ha ng tamang answer. Sino to? Nag-round up yung iba, ginawang 1.8. Sige, Angela Dominguez. Paki-message sa Schoology sa inbox yung solution ninyo as in now na. I want to see your solution before I'll give you the exemption for the next quiz. Angela Dominguez, Juliana Molano, Baligasa, Maralit. Hanggang kay ano lang yun sabi ko kanina. Hanggang kay Courtney. Okay. Hanggang kay Courtney lang yon. Kasi nag-start na ako solve after that. So yung mga late na nag-submit, hindi ko na ito tatanggapin ha. So, saan na yan? Baligasa. And then, Guanzon. Ay, bakit 117.65? Anyway, let me see your solution. And Magallanes. Kindly send me your solution sa inbox. I want to see that. The rest, plus, hindi na ito nakahabol ha. No, not in the messenger. Matatabunan kasi yan sa messenger ko. Marami masyadong tama na messenger ko. Doon sa inbox ng ano. Doon sa inbox ng Schoology. Now na ha. Yun lang mga binanggit ko. Yung iba, wala na yun. Okay. And copy the writings on the screen. Again, this one is a bit difficult. So you really have to analyze the problem. This is looking for the molar mass class. So ito yung first step dito nasa baba. First, look for the change in the freezing point temperature using this formula here sa baba. And then this is the second step here. After getting the change in the freezing point temperature, get the molality. If you have now the molality, compute for the moles. So this is the third part here. Compute for the moles. If you have the moles now, the last part of the computation here, the fourth one, is computing for the molar mass. Okay? Ngayon na-send na yung ano, time check. Pag nag-sobra yan, hindi ka na tatanggapin. Hanggang 8:35 lang. Yung pag-send.
Asa ipasa mo?
Sa inbox sa Schoology.
Message?
Oo, sa message. Hanggang 8:35 lang ng time ha. Para exempted sa sa quiz next meeting. I want to see the solution. Okay, I'll be erasing the writings on the screen now. Okay, any question or clarification about the freezing point depression? Or tayo mag-move on sa osmotic pressure. Let me check my inbox. Natulugan ko. Okay. Ito na lahat yun. Baligasa, Maralit, Dominguez, Magallanes. Diyan naman na Dominguez na receive ko na. Let me review that. Molano. Where is your solution? Molano. Oops. Wait lang ha. I think I missed something. Dominguez. Molano. Baligasa. Guanzon. Magallanes lang pala. Hindi pala kasali si Maralit. 1.2 pala itong answer mo here. It should be 1.7 or 1.8. Hindi pala ito kasali, Lauren. Okay, hanggang 8:35 lang yan ha. Para mahabol yan. Anyway, magre-reflect naman sa akin anong oras niyo siya sinend. And then, I'll confirm later kung exempted ba talaga kayo sa quiz next meeting or hindi. Let me check your solutions first. Okay, so let's move on with the osmotic pressure. Okay, this is the last one, the last colligative property. So pag sinabing osmotic pressure, it's a different pressure ha, kasi marami tayong pressure na diniscuss. When you say osmotic pressure, it's the pressure na needed or required to stop the flow of the solvent or to stop osmosis. Ano ba yung osmosis class? Osmosis is the movement of our solvent. Take note, ano yung mag-move? It's the solvent molecules. Ang mag-move from a region of lower solute concentration to one with a higher concentration. So you can see that in the illustrations sa screen. We have two beakers here. And sa each of the beaker, you can see class the compartment. Merong division. This region, this first region here has lower solute concentration. Yung mga bilog-bilog dyan, it's the amount of solute. And then the second compartment has more solute. So when you say osmosis, the solvent will move to the region with a higher solute concentration, it will become like this. Okay, so as you can see, walang solute na nag-move ha, solvent lang. So nakikita niyo sa compartment number 1, the solute remains the same but the solvent has decreased. Okay? And saan napunta yung ating solvent? Nandito na siya sa compartment number 2 or the region with higher solute concentration. Kasi our purpose or our goal for osmosis is dilution. Okay? Again, that is our goal for our osmosis, dilution. We are going to dilute the solute. Again, the movement of that is called osmosis. And when you say osmotic pressure, it's the pressure needed to stop the movement or to stop osmosis para hindi na mag-move yung solvent from one region to another. That's the meaning of osmotic pressure. So let me give you an example of osmotic pressure that happens in our own body. So una, question muna. Ano yung mostly naririnig niyo kapag hypertensive ang person? Ano yung bawal? Anong pagkain yung bawal? Pag hypertensive ang tao. Pag may high blood ang tao. Ano mostly ang naririnig niyo? Anong pagkain?
Pork, ma'am.
Ha? Sira? Sorry, wala akong kamatay. Wala, dili siya audible. Okay. Nakita ko na ang answer. Fatty foods are actually prohibited, no, for I mean you need to control that one for hypertensive persons or those with heart diseases, and even with mataas na cholesterol, yung may mga mataas na cholesterol na ano natin. Pero yung mostly maririnig natin, 'di ba? Sa hypertensive na tao, kailangan less ang intake ng salt. Tama? Narinig niyo na 'yan? Na kailangan bawas-bawasan yung salty na pagkain for hypertensive na person. Bakit? Pag sinabing blood pressure class, syempre this is our blood vessel. You know this very well. You have your phlebotomy. So we have here our blood. And for our blood to flow, para mag-flow yung blood natin, kailangan yan ng pressure. So the blood pressure is required for our blood to flow. Okay? Naintindihan yan ha? Now, anong connection ng salt na yan? Pag ang person is into salty foods, for example, maraming asin, yung sa blood class, dadami din ang sodium. Kasi galing to sa kinain eh. Mapupunta yan sila lahat dyan sa blood. And the sodium class is considered as a solute. Okay, solute yung salt na yan. Now, what will happen in the body if you have a lot of sodium in the blood? Osmosis will be activated. Anong meaning sa osmosis? Movement of the solvent. Meaning yung water natin sa body, our universal solvent, marami tayong water sa body, mag-move yan siya. So, saan siya pupunta? Since marami ang solute dyan, higher concentration yung solute dyan sa blood, yung water from the other parts of our body, from our cells, mag-move and mapupunta sa blood. Okay? Now, anong mangyayari? Siyempre, tataas yung volume ng blood. Kasi nadagdagan siya ng water na nag-move because of the presence of a lot of solute, which is the sodium. So sodium chloride or our salt. Now, pag tumaas ang volume ng blood, ganito pa rin kalaki yung ating yung ating blood vessel. Tumaas yung blood volume. Hindi nag-adjust si blood vessel. So para mag-flow itong marami na volume ng blood, syempre kailangan yan ng mas malaki na pressure. So that will mean tataas ang blood pressure class. This is the explanation why salty foods are like not really that prohibited, pero you really have the hypertensive person has to lessen the salt intake kasi makaka-add up siya doon sa pag-increase ng blood pressure. Osmosis yung mag-e-explain dyan. So if you have someone in the family that is who is hypertensive, please be mindful. Please remind them, about lessening the intake of the salt. Okay, that's an example class of osmosis that takes place inside our own body. Okay, nakuha yan. Parehas lang gud siya sa host class kanang magdiligod ta. Magdilig ta no gamit tag host, di ba? Pag i-increase natin yung water volume kay nag-i-increase nato ang gripo, gipakusgan nato ang gripo. Di ba? You can feel the pressure para mag-flow ang water. nya kay ang host wala man siya nag-expand, parehas man lang gihapon ang iyahang size. So mo na nga mutaas ang pressure para ang flow sa water mokusog sad. Ingana pud ang atuang blood. Ang atuang blood vessel hindi siya mag-a-adjust, pero if we intake a lot of salt, dadami yung blood volume natin because of osmosis. The water from the other parts of our body will move to our blood, kaya mag-i-increase ang blood volume, and that will mean increase in the pressure also na kailangan for our blood to flow. So yung result niya talaga is increase in the blood pressure, and the person will have a condition called hypertension. So I hope that is clear. Now, again, osmosis yan ha. Osmosis ang explanation yan. There is movement of solvent from a region of lower solute concentration to one with a higher concentration. Now, we need osmotic pressure to stop the flow of the solvent. That's the meaning of osmotic pressure. Okay? Now, this is very important sa inyo, ha? Actually, sa mga medical practitioners class, kasi it's not really right to inject any substance sa atuang blood vessel. Hindi pwedeng basta-basta ka na lang mag-inject ng kahit ano, ha? So solutions that is to be injected into our body must have the same osmotic pressure with our blood serum. So when you say the same yung osmotic pressure ng substance na i-inject, that means it should be isotonic with blood. When you say isotonic with blood, it has to have the same salt content with the blood. Okay? So do not inject pure water into the blood vessel. As remember, pure water is just a solvent, wala siyang solute. So definitely it's not isotonic with our blood serum, since our blood serum contains a lot of solute. May sodium, may potassium, and so on. So hindi ka pwedeng mag-inject basta-basta ng tubig lang. Hindi ka din pwedeng mag-inject ng kahit ano. For example, gumawa ka ng sarili mong solution and i-inject mo yun siya sa blood. Aside from the risk of poisoning and toxicity, again, you have to make sure first that the solution that you're going to inject has the same quantity of solute with that of the blood. Now, we have the so-called hypotonic solution. Okay? Again, we have hypotonic solution. Ito yung mga solutions natin, class, that have lesser concentration compared to our blood. Okay? Lesser yung hypotonic. Lesser ang solute concentration sa blood. Now, paano kung na-inject natin yung hypotonic solution natin sa ating blood vessel? Okay? So, if injected in sufficient quantity to dilute the blood serum, water from the diluted serum passes into the blood cells by osmosis. This will trigger osmosis, class, causing the cell to expand and rupture. Mag-e-expand ang ating cell and magra-rupture. Wait lang, I have the illustration here. Later na lang yan. I-draw ko na lang siya. So, for example, this is our blood vessel. We have the blood here. And remember, we have solute, class. Meron tayong mga solutes sa blood, di ba? Meron tayong mga electrolytes, sodium, potassium, magnesium, calcium, and so on. Now, paano kung nag-inject ka sa body, for example, ng hypotonic solution? I mean, sa blood vessel. And then outside, this is the blood vessel, and then syempre may mga tissues pa na nakapalibot dyan. And sa tissues, meron din dyan solute, diba? Meron din tayong solute anywhere else in our body. Meron pa rin mga sodium, potassium, and so on dyan, hindi lang sa blood. Okay? Now, pag nag-inject ka dito ka nag-inject ka sa blood, kasi diba nag-i-inject tayo intravenously Tapos ang in-inject natin is hypotonic solution. And when you say hypotonic solution, less solute, more solvent. So in this case, the solvent is most likely water. So dadami yung water dito, class, dadami yung solvent. Pero hindi naman nag-increase talaga yung solute kasi nga more water yung ating in-inject. This will trigger, class, osmosis kasi ang mangyayari, mas marami na yung solute sa labas ng blood vessel kaysa sa tissues natin. Baliktad pala. Mas marami na yung solute dito sa tissues natin kaysa sa nasa blood natin. So, ang mangyayari, mag-move yung water coming here from the blood vessel. Saan siya pupunta? Siyempre sa mga tissues. And when you say tissues, mga cells, it is made up of a lot of cells. So, pupunta dito yung water, class. Example, this one sa cell na ito, pupunta siya dyan. Papasok yung water dito kasi mas marami na yung solute kaysa sa blood. So ito yung ibig sabihin ng the cell will expand since magdadami yung tubig niya. And after that, kung malaki na siya masyado, the cell will rupture or mag-undergo ng hemolysis. So this is why I told you a while ago that as much as possible, we only inject isotonic solutions. Hindi tayo basta-basta mag-i-inject ng hypotonic kasi ito yung mangyayari. Example, ito red blood cell lang ito ha, yung example ko kanina kasi outside the tissues. Outside the blood vessel. Ito, kung sa blood, meron din tayong cell sa blood, the red blood cells. Okay? And then nag-inject ka ng hypotonic solution na maraming tubig. So, ang mangyayari, there will be osmosis. Papasok ngayon yung tubig sa red blood cell, causing it to swell. And then, kapag masyado na siyang malaki, magbo-burst na siya. Okay? That is the risk of injecting a hypotonic solution. Ganyan din yung mangyayari kung pure tubig lang talaga ang i-inject natin. Okay? Pure tubig lang. So, ang mangyayari kasi kung pure tubig lang, konti kasi yung solute dito sa blood. Mas marami actually ang magiging solute dito sa loob ng red blood cell. So, yung in-inject mong tubig, papasok yan lahat dito. And then again, mag-burst yung red blood cells na yan. Pero kasi, pag isotonic solution lang yung ating i-inject, saan na yun? Hindi. Nasaan na yun? Pala. Pag isotonic solution yung i-inject natin, when you say isotonic solution, it has the same solute with that of the blood. So, mangyayari niyan, the same, equal lang. So, number of solute dito sa blood and actually number of solute dito sa loob ng cell, equal lang sila. So, it will not really trigger osmosis. So, walang mangyayari sa cell natin. We will just have normal red blood cells compared with this one. Pero kung hypertonic is a more concentrated solution, meaning marami siyang solute. This will also trigger osmosis pero baliktad. Okay? Baliktad siya. Nag-inject tayo ng maraming solute, example sa blood. So, mangyayari, itong blood na ito, marami na masyado siyang solute. This will become a region of higher solute concentration. And then, ang mangyayari, since kulang na ng tubig dito or ng solvent, yung tubig sa cells, example, red blood cells, mag-o-osmosis yan siya. Pero, yung movement niya is palabas. Okay? Kasi maraming solute dito kailangan niyang i-dilute. So, ano mangyayari sa red blood cells natin? Mag-shrink sila. Okay? Mag-shrink. And ang tawag natin dyan sa shrinking of our cell is crenation. Okay? Mag-shrink. Mawawalan ng tubig yung ating mga red blood cells if we are going to inject hypertonic solution. So, be careful of what you are administering to the patient, especially if it is direct intravenous na injection. Okay? Now, I think lahat tayo nakatry ng ma-hospital. Tama? And meron tayong fluid replacement therapy. Most of us call it dextrose, pero hindi naman talaga yan lahat dextrose. Okay? Do not call the fluid replacement therapy as dextrose if hindi talaga siya dextrose. Marami kasing klase yan, yung IV fluid na nilalagay sa kamay natin kapag na-admit tayo sa hospital. Tingnan nyo muna yung nakalagay kung dextrose ba talaga siya or hindi. Dextrose is glucose. That's our physiological sugar. Pero most of the time kasi hindi dextrose ang binibigay pag na-admit kayo sa hospital. Kung titingnan ninyo ang nakalagay dyan, PNSS. Plain, normal, saline solution. Ito yung mostly binibigay. And ang color ng lalagyan nito is color green. So, hindi yan siya dextrose ha. It's just plain NSS. Kasi pag dextrose ang nilagay sa inyo, ang nakalagay talaga dyan sa, sa label is dextrose. Okay? So, ito class, yan sila mga fluid replacement therapy. They are considered isotonic with blood. So, if you are going to be injected with these chemical substances, wala kang mafe-feel na sakit, normal lang siya. Walang mangyayari sa'yo kasi there will be no osmosis. So ang isotonic with blood is itong plain NSS, and ang concentration nito is actually 0.9% NaCl solution. Ito lang yung binibigay sa atin pag naho-hospital tayo, 0.9% NaCl solution. So this one is isotonic with blood. And there will be no osmosis for this. Okay? Any question? It's already 8:54. We will have the computation for the osmotic pressure next meeting.